Good afternoon to all my evaluators. My name is Tan Wei Chen, the team leader of MY125. This is our project title, Design and Development of On-the-Go Soil Fertility Measurement by using ATV. These are my team members, which are Muhammad Muslim and Muhammad Afiq. We are from University Technical Malaysia Melaka, and we are from Fakulti Kejuruteraan Elektrik. First of all, this is our problem statement. Our customer is Mr. Tan Sui Huat, with 55 years old, with the profession farmer and the owner of palm oil and durian field. These are the problems faced by Mr. Tan. He has watering the seedling of the tree every morning and fertilizing the tree every month. However, the leaf of the seedling has become yellow. The question is, why? Is the water not enough, sunlight not enough, or the soil nutrient not enough? So, we're having some common problem that we have faced in the agricultural activity. First, Mr. Tan has watering the plant every day, so we can sure that there is no problem in terms of water, and the sunlight provided are also enough, so maybe it's from the fertilizer. Now, the traditional method of analysis the soil property are the laboratory analysis. This way of analysis are collecting the soil sampling in 1 to 3 hectare. However, the result of the analysis take 2 to 3 months to be complete. This method having a big weakness, which are require human energy to collect the soil sample, and the results are inaccurate since the soil availability changes from time to time. So, we propose our solution, which are having a real-time and on-the-go soil nutrient analysis system with mobile platform and automated soil sample collecting system. This system able to monitoring the condition of soil nutrient in the farm by using the ATV as a mobile platform to collect the data. And the data will combine with the GPS technology and sent out to the crop service. The data can be monitoring using the monitoring system such as the phone or laptop or PC. Now I would like to compare the mobile platform that we select to other mobile platform. The mobile platform that we have select is ATV. The ATV having a stable performance that able to travel in many type of environment, which including the muddy and sandy field. The tractor and ATV having a stable stability compared to the drones due to their four-wheel design. The drones are require skillful pilot to control it. For the operation space, the ATV having a smaller operation space compared to the tractor. The ATV can easy to travel inside the field, and the tractor having a bigger size is hard to travel in the fields of palm oil and durian farm. For the maintenance and services, the maintenance and services of the ATV is more easier compared to the tractor. For the load that can be carried by the mobile platform, the tractor having a heavy load carry compared to the others due to the big size of the tractor. The ATV able to carry the medium size of the load, which are suitable for our project, which only install the soil collecting attractor and the sensor behind the ATV. For the drones have light load carry. Drones are not able to carry the soil sample collector attractor compared to the ATV because the drones are more suitable by using the UV sensor, and it is not suitable for the soil fertility analysis. Next, we will compare amongst the soil proximal sensor that we have select. The soil proximal sensor that we have select is ion selected electrode sensor. ion selector electrode sensor having a small size compared to the penetral logger, and the working principle of the ion selected electrode sensor is based on the ion selected. The ion selectors are important for our project due to the main objective of our project is to analyze the concentration of the ion content in the soil, and the ISE sensor are able to measure the micronutrients such as nitrate, potassium, and phosphorus of the soil. The weakness of the ISE sensor is the sensor can only measure the soil micronutrients in the aqueous solution. So we need to mix the soil with the water to allow the sensor to analyze the soil nutrient content in the soil. Next, for the EC sensor compared to the ISE sensor, EC sensor also able to analyze the soil nutrient by using the electrical conductivity. However, this is also the weakness of the EC sensor due to the soil nutrient measurement by using the EC will be affected by the moisture of the soil. For the penetral logger having a big size compared to the ISE sensor and EC sensor, which make it more harder to carry. The way of the penetral logger to collect the sample is by using the vertical breaking force of the soil. The weakness of the penetral logger is the vertical breaking method will harm the root of the plant. For the demo and user feedback, the prototype of the soil nutrient analysis device has been fabricated in a tooth box and has been run test in the palm oil field of UIT and Jasin. These are the feedback from the user. The system is easy to be carried, the GPS detection is accurate, and the data collection is fast. The target segment and the impact is the target of the system is the farmers. The farmer population in the world are 26.7%, which are 2 billions of people, and the impact of the system is the system able to analyze the variability of the soil nutrient, and the fertilizing can be done through the fertility mapping. By using the fertility mapping, the waste of the fertilizer can be minimized, and this can prevent the degradation of the environment. This is the system configuration of our products. For the inputs, the soil and water will be mixed together using the mixer, and the soil nutrient will be analyzed by using the ISE sensor. After that, the data will be combined with the GPS and sent to the Raspberry Pi and Arduino Uno. From the Arduino Uno, data will be stored in the SD card, USB, and the data will also store at the cloud service and display by using the LCD. After that, the soil mixture will be pulled back to the farm. This is the soil sampling method that we have used. The depth of soil that we collect is 20 cm, and the sampling area is in 1 to 2 hectare. The distance between our sample is 10 meter for each sample, and the sampling method is using the grid point sampling. For our mechanical part of ATV, the soil sample collector actuator was installed with soil mixture and water pump. And for the sensors, we can see that we're using the ISE sensor to detect the soil nutrient in terms of nitrate and potassium, and we're using the new GPS sensor as our GPS tracker, and we're using the Arduino Uno and Raspberry Pi Model 4 as our controller. For the software, we're using the Node and Python to control our controller, and the QGIS was used to create the fertility mapping. This is the sensory setup of our system. From the diagram, we can see that the LCD display was connected with the Raspberry Pi, and the new GPS was connected with the Arduino Uno. After that, the Arduino Uno board was connected with the Raspberry Pi by using the serial port. The ISE sensor also connect with the Raspberry Pi by using the serial port. For the result and discussion, from the UITN Jasin, we have collect 42 sample of soil, and by using the system that we developed, the GPS and soil nutrient concentration are recorded in CSV file. This is the user interface of our system. The user interface will always monitoring the real-time coordination of the system and the soil nutrient collected by the sensor, also the battery percentage of the sensor that we use. This is a sample of the fertility mapping that we have formed from the 42 sample of UITN Jasin, and we proceed to the project demo. This is the video of the mechanical part of my project. In this video you can see that the soil collecting attractor will move down to collect the soil and put into the mixer, and the mixer will mix the soil and the water together. After that, the soil will be pulled out from the mixer. Now I would like to demonstrate the operational function of the sensory prototype of my project. As we can see, this is a LCD display connected with the Raspberry Pi controller, and the new GPS device was connected with the Raspberry Pi controller also, and these two are the ISE sensor used to analyze the soil nutrient. To analyze the soil nutrient, we need to mix the soil with the water, and then we need to immerse our ISE sensor into the liquid solution that we have made with soil. After the ISE sensor has immersed into the soil liquid solution, we can start our soil nutrient analysis by running our program in the Python. Next, I will proceed to the software operation of my project. We can control our system through the laptop by using the VNC viewer, and this can help us to monitoring our system through the different displays. This is the Python program that we have used to start our soil nutrient analysis test. The sample that we have taken is 20 samples. To start our soil nutrient analysis, we need to click the run button and select the sensor we need. The sensors selected are depend on the device, and we select 2 for the nitrate and 6 for the potassium. After that, we select the period for each sample take. We select 1 second for each second take, and we can see that this is the result taken by the sensor. This is the flow of the node rate, and from here we can see that this is the interface that real-time monitoring the sample collected. After finish the sampling, we can see that the program will quit immediately, and the sample collected will set as a CSV file. This is the sample of data that we can get from the system. This is the sample from UITN Jasin. The timestamp, coordination, and soil nutrients are recorded and saved as the CSV file. From this CSV file, we can form a soil fertility mapping. The fertility mapping can be formed by using the data collected. The farmer can view the property of the soil sample by opening the attribute table, and by using this mapping, farmer can easily understand which locations are lagging of the soil nutrient nitrate. So, farmer can providing the fertilizer depend on the fertility mapping. In conclusion, the system developed able to analyze the soil nutrient in terms of nitrate and potassium content in the soil, and the farmer are able to do the fertilizing based on the fertility mapping that have created by the system. This can able to minimize the waste of fertilizer in the agricultural activity, and the system can be improved by adding a soil moisture analysis system or automated watering system, and even more automated fertilizing system. That's all from me. Thank you.